An Edison circuit is a type of electrical circuit where the neutral and hot wires run in parallel along the same conduit or wall cavity. It typically has a two-wire configuration consisting of a hot and a neutral wire. Edison circuits can have multiple branches, meaning multiple outlets and lights can be connected to it. For overcurrent protection, it requires a fuse or a circuit breaker. Edison circuits are generally easy to install and maintain, making them suitable for low amperage appliances and lighting. However, Edison circuits can cause voltage drops and imbalances due to uneven distribution of load among the branches and are not recommended for high power appliances or heavy electrical loads. A multi-wire branch circuit, often abbreviated as MWBC, is another type of electrical circuit where two hot wires and a shared neutral wire run in parallel along the same conduit or wall cavity. Unlike an Edison circuit, a multi-wire branch circuit has a three-wire configuration comprising two hot wires and one neutral wire. This configuration permits two separate branch circuits to share a single neutral wire. Each hot wire supplies power to a different circuit. Multi-wire branch circuits offer the advantage of saving space and materials by sharing a neutral wire. They also provide two separate circuits with independent overcurrent protection and can supply more power than an Edison circuit. However, multi-wire branch circuits require special double-pole circuit breakers or fuses. They can be more complex to install and maintain, and if the neutral wire becomes open, both circuits will lose power. To summarize the key differences, firstly, the wire configuration. An Edison circuit has a two-wire configuration with a hot and a neutral wire, while a multi-wire branch circuit has a three-wire configuration with two hot wires and one neutral wire. Secondly, the number of circuits. An Edison circuit supports multiple branches, while a multi-wire branch circuit supports two separate circuits. Thirdly, the neutral wire configuration. An Edison circuit has a dedicated neutral wire for each circuit, while a multi-wire branch circuit has a shared neutral for both circuits. Fourthly, overcurrent protection. An Edison circuit requires a single fuse or circuit breaker, while a multi-wire branch circuit requires double-pole circuit breakers or fuses. Fifthly, load capacity. An Edison circuit is limited to low amperage loads, while a multi-wire branch circuit can supply more power than an Edison circuit. Finally, complexity. An Edison circuit is easier to install, while a multi-wire branch circuit is more complex to install and maintain. In terms of suitability, Edison circuits are best for low amperage loads and lighting, while multi-wire branch circuits are better suited for higher power appliances and heavy electrical loads. Considering these differences, it's clear that the choice between an Edison circuit and a multi-wire branch circuit depends on the specific electrical needs of the application. For simple lighting and low-power devices, an Edison circuit might be sufficient. However, for situations requiring more power and the ability to run two separate circuits, a multi-wire branch circuit would be more appropriate. When considering electrical circuits, it is also important to understand some fundamental concepts such as voltage drop and load balancing. Voltage drop refers to the decrease in voltage along a conductor as electricity flows through it. Excessive voltage drop can cause appliances to function inefficiently or not at all. In Edison circuits, uneven distribution of load among the branches can lead to significant voltage drops, particularly if some branches are heavily loaded while others are lightly loaded. Multi-wire branch circuits, on the other hand, can help to mitigate voltage drop by providing two separate circuits that can be balanced to distribute the load more evenly. Load balancing involves distributing the electrical load across multiple circuits or phases to prevent overloading any single circuit or phase. In a multi-wire branch circuit, the two hot wires are typically connected to different phases of the electrical supply. This helps to balance the load and reduce the risk of overloading the neutral wire. Overcurrent protection is another critical aspect of electrical circuits. Overcurrent protection devices, such as fuses and circuit breakers, are designed to interrupt the flow of electricity if the current exceeds a safe level. This helps to prevent overheating, fire, and damage to electrical equipment. In Edison circuits, a single fuse or circuit breaker is typically used to protect the entire circuit. In multi-wire branch circuits, double-pole circuit breakers or fuses are required to protect both hot wires simultaneously. This is important because if one hot wire is overloaded, the other hot wire may also be at risk of overheating. It is also important to consider the National Electrical Code, often abbreviated as NEC, requirements for electrical circuits. The NEC provides detailed guidelines for the installation and wiring of electrical systems to ensure safety and prevent electrical hazards. Some relevant NEC sections for Edison circuits and multiwire branch circuits include 210.4, which covers branch circuits, 210.20, which addresses overcurrent protection, and 300.13, which discusses the continuity of the neutral conductor. Section 210.4 specifically addresses multiwire branch circuits and outlines the requirements for identifying the grounded conductor, the ungrounded conductors, and the conditions under which a multiwire branch circuit can be used. Section 210.20 details the requirements for overcurrent protection of branch circuits, including the ampacity of the overcurrent devices and the types of overcurrent devices that are permitted. Section 300.13 emphasizes the importance of maintaining the continuity of the neutral conductor in electrical circuits, which is particularly critical in multi-wire branch circuits. The NEC also provides guidance on the proper wiring methods for Edison circuits and multi-wire branch circuits, including the types of conductors that can be used, the ampacity of the conductors, and the methods for terminating the conductors. These guidelines are intended to ensure that electrical circuits are installed safely and reliably. In addition to the NEC, local electrical codes may also apply to Edison circuits and multiwire branch circuits. Local codes may have more stringent requirements than the NEC, so it is important to check with the local authority having jurisdiction before installing any electrical wiring. In summary, the choice between an Edison circuit and a multiwire branch circuit depends on the specific application and the electrical load requirements. Edison circuits are suitable for low amperage loads and simple lighting applications, while multiwire branch circuits are better suited for higher power applications and where two separate circuits are needed. When installing either type of circuit, it is important to follow the NEC and local electrical codes to ensure safety and prevent electrical hazards. Considering specific scenarios will further highlight the practical differences. Imagine a small workshop needing power for lighting and a few small power tools. An Edison circuit could handle the lighting and one or two low amperage tools, but if multiple tools are used simultaneously, it could easily overload the circuit, leading to trip breakers and potential voltage drops affecting tool performance. Alternatively, consider a kitchen with the need to power a microwave and a toaster oven. These appliances draw a significant amount of power. Using a multi-wire branch circuit would allow the microwave and toaster oven to operate on separate circuits sharing a neutral wire, preventing overloading and ensuring each appliance receives the necessary voltage. The implementation of ground fault circuit interrupters, often abbreviated as GFCIs, is critical for safety in both Edison and multi-wire branch circuits, especially in areas prone to moisture like bathrooms and kitchens. A GFCI is designed to detect even small imbalances in current, quickly cutting off power to prevent electrical shocks. In the context of multi-wire branch circuits, it's vital to ensure that when using a GFCI, it is a double pole type that breaks both hot wires simultaneously to prevent any potential differences in voltage that could cause a shock. Understanding the concept of harmonics is also important, particularly in commercial and industrial settings where nonlinear loads such as electronic devices and LED lighting are prevalent. Harmonics are distortions in the sinusoidal waveform of alternating current that can cause overheating of neutral conductors, especially in multi-wire branch circuits where the neutral carries the sum of the harmonic currents from multiple circuits. To mitigate harmonic issues, it may be necessary to use oversized neutral conductors or install harmonic filters. When designing and installing electrical circuits, it is also essential to consider the impact of electromagnetic interference, often abbreviated as EMI. EMI can be generated by various electrical devices and can interfere with the operation of sensitive electronic equipment. To minimize EMI, it is important to use shielded cables and to properly ground all electrical equipment. Furthermore, The physical installation of the wiring plays a significant role in the safety and efficiency of both Edison and multiwire branch circuits. Ensuring that the wiring is properly supported, protected from physical damage, and installed in accordance with the NEC guidelines is crucial. This includes using appropriate conduit, cable clamps, and junction boxes. Regular inspection and maintenance of electrical circuits are also essential for identifying and addressing potential problems before they become serious hazards. This includes checking for loose connections, damaged wiring, and corroded components. In addition, it is important to periodically test GFCIs to ensure that they are functioning properly. The selection of appropriate wiring gauges is paramount for both Edison and multiwire branch circuits. The gauge of the wire must be sufficient to handle the anticipated load without overheating, which could lead to fire hazards. The NEC provides tables that specify the allowable ampacities for different wire gauges based on the type of insulation and the ambient temperature. When working with multiwire branch circuits, it is especially important to ensure that the neutral wire is of adequate gauge to handle the potential imbalance in current between the two hot wires. The use of arc fault circuit interrupters, often abbreviated as SIs, is another important safety measure to consider. SIs are designed to detect arc faults, which are dangerous electrical conditions that can cause fires. Arc faults can occur when there is a break in the insulation of a wire or when there is a loose connection. SIs are particularly effective at preventing fires caused by damaged or aging wiring. In conclusion, the choice between an Edison circuit and a multi-wire branch circuit involves careful consideration of various factors, including the electrical load requirements, safety considerations, and compliance with the NEC and local electrical codes. While Edison circuits are simpler to install and maintain, multi-wire branch circuits offer greater efficiency and capacity for handling higher power loads. Proper design, installation, and maintenance are essential for ensuring the safe and reliable operation of both types of circuits.